Hey guys, Miss Marflack here. In our last video, we went over how to solve exponential equations. We looked at those two types where we had the same base and then we could not have the same base, so we used logs to solve. And then now we're moving on and we're going to be solving logarithmic equations, which means now we're going to be starting off with a log in the problem. Now there are a few different ways to solve these log equations, and we're going to go through each type and then we're going to be mixing them in together. Now keep in mind that this lesson will span over the course of 2, maybe even 3 videos. So we're not just spending one day on this topic, but we're probably spend 2 or 3 days in total on this topic. The first type of log equation that we're going to solve together is log equations where we can use the definition to solve. And I know it's been a while since we've seen the definition, so I'll rewrite it for us. But that definition was when we have our log base b of x is equal to y, we were able to rewrite that as b to the y is equal to x. And then keeping in mind that that was our scooping and looping around. So we're going to be able to solve some of these log equations simply by writing them in exponential form to solve. Now we do have to be careful because there is a condition with our log definition, and one of the conditions was that our x has to be greater than 0. All right, can't be equal to 0 and it can't be a negative number. So we're gonna have to be really careful when we get our final answer, like x equals 4, x equals 5. We have to plug it back in and make sure we're gonna get out a positive answer when we evaluate there. All right, we're gonna take a look at this first example here, and we have log base 4 of x plus 3 equals 2. Silly me for not putting in the directions. Our directions here are to solve. All right, and solve means we're solving for that x. All right, so our goal is to solve for that x. We're going to use a definition to solve for it, which means we're going to rewrite in exponential form, scoop, and loop around. All right, rewriting this here, that's going to be 4 to the second power is equal to x plus 3. All right, 4 to the second power is equal to x plus 3. Well, 4 squared is 16, and that's going to be equal to x plus 3. And then we solve for x, and I'm just going to switch sides here, and we get x is equal to 13. Now, we do have to do a check. As we go along and we start doing more and more of these problems, this check can be mental. Okay, so I'll say it again. As we do more and more of these problems, this check can be mental, all right? But for the first one, I am going to write it down for us so you know what I'm kind of thinking in my head. And that's, well, if I plug this answer I got in for x, is my domain positive? Right, or greater than 0. Now, I'm not just interested in the x. The x may be a negative number, but when you plug it in, you may get a positive number. So I'm just interested in this domain here. Is it positive? Yes, it is, which means that this x equals 13 is my final answer, okay? This is my solution there. All right, we're moving on to number 2 here, and we're going to have log of 3x plus 1 is equal to 5. All right, we're going to scoop and loop and use that definition. I have my common log, and I'm scooping and looping around. We're going to rewrite this in exponential form, and that's 10 to the 5th power is equal to 3x plus 1. All right, now my goal is to solve for x, so we're going to expand that 10 to the 5th power, and that's going to be 5 zeros, which is 100,000. And then we still have that 3x. Subtracting 1 from both sides. If you're not comfortable with your number sense, that's okay. Use a calculator, and then dividing by 3, and we're going to get 33,333 as our x answer. Now, I do need to do this mental check over here, and that's if I plug in my x value, is my domain in parentheses going to be a positive number? And when I check here, all right, I don't need to actually multiply and add. I can see that this is going to end up being a positive number, which means that x is my solution. So you always need to do this check, whether it's off to the side or whether it's mental, ensuring that x is greater than 0, like in our definition. All right, moving on here, number 3. We have another log base 2 x minus 4 equals 3. All right, we're going to scoop and loop around, use that definition. Well, 2 to the 3rd power is equal to x minus 4. 2 to the 3rd power is equal to x minus 4. And then we're going to expand that left-hand side. Well, 2 to the 3rd power is 8. and then we're going to solve for x by adding 4, and we're going to get x is equal to 12. Now, I don't care about this. I care about the domain, whether that's going to be positive. So I do need to go back and I need to check. Plugging in that x for 12, and I'm interested, is this number here a positive number? And 12 minus 4 will be a positive number. And there we are, we get x. Now this is maybe a good example to kind of illustrate, well, if this was 3 and I did 3 minus 4, then it would be a negative number, and then it would not be a solution. All right, there's number 3. Moving on to number 4, we're going to have log 2x equals -1. Now most of your homework is going to have base 10, even though we did see an example with base 4 and base 2, but most of your homework will be base 10. All right, we're going to scoop and loop around. We're going to rewrite this in exponential form. 10 to the -1 is equal to 2x. And then here we are, 10 to the -1 is equal to 2x. All right, well, I know 10 to the -1 using that property of exponents is 1 over 10 to the first. Or you can use a calculator and get 0.1. Okay, you can use a calculator. And then I'm going to divide by 2, and that's going to be 1 over 20. And you can also give me a decimal approximation there. And then now we're doing this check over here, and we're seeing, if I plug in this x, is my domain going to be a positive number? And I look here, and even though it's going to be a fraction, 2 over 20, which is 1 over 10, 1 over 10 is going to be a positive number. So there is my answer for x. All right, I think we have one more here for this type of problem, and this is going to be 5 log x is equal to 5. Now, starting off with this problem here, there is 2 ways to do it. So we're going to break off into this first method, and then we're also going to do it a different way over here using a different method. So I'm going to write this out as 2 different problems, but they are going to be the same answer. I'm just doing them 2 different ways. All right, taking a look here at this one, the first thing I see is I see that 5 in front, and I want to isolate my log before I scoop and loop around. So I'm going to get this log by itself by dividing by 5. All right, so I could do that first, divide both sides by 5. And then now I can scoop and loop around, and I'm going to see that I have 10 to the first is equal to x. And I'm going to rewrite this in exponential form. Well, that's 10 to the first is equal to x, and I see that x is equal to 10. And then when I go ahead and I plug it back in, just to double check here, making sure that that domain is going to be positive. Yes, it is positive. So this is my answer. It is positive. All right, I don't think you see that plus, and then now you see it. Perfect. All right, and then now we're going to show you how to do this same problem a different way. So maybe instead of dividing by the 5, you decided to use your power property first to condense, power property to condense. And then now that you've condensed using the power property, you can scoop and loop around and rewrite this as 10 to the 5th power is equal to x to the 5th power. All right, and then we could see that they're both raised to the 5th power, which means that x here is 10. And then doing that check again, you're going to get the same thing, and it will be a solution. All right. This example is a great kind of bridge to our next method of solving for these log equations. And that next method, putting another star here, is using log properties. All right, now it's actually not that different from the first method, except now you're going to use the properties to condense. And then once you've condensed, then you're going to use a definition. All right, once you condense, then you can use a definition. All right, now we're going to have 2 types of log property problems. We're going to have log on one side, which we're going to look at today, and then tomorrow in our next video, we're going to take a look at log on both sides. All right, here we are. We're going to start off with number, I think we did 5. Yes, we did. We did 5 of the other type, and here we are 6. So we have log of x minus log of 3 is equal to 2. All right, so now we have these two logs. I need to condense first using my properties. I have subtraction with two logs, which means I can go ahead and I can do division with one log. And those of you who remember that, that is your quotient property. And then now that you've condensed to one log and a number on the other side, then you could use the definition and you can scoop and loop around. So now that you've condensed, you could scoop and loop around, and I have 10, because it's common log, squared is equal to x over 3. And then 10 squared is 100. And then solving for x, multiplying both sides by 3, I get 300 is equal to x. And then now I'm going to kind of do a mental check. And I'm going to put this 300 in here. I get a positive domain for my log. I don't have to put it in here. This is a positive domain. So yes, this is an answer. Okay, so we're going to highlight that. That is our answer. All right, so it's just like the other problems, except now we maybe have this extra step or two at the beginning where we're condensing one side completely before we scoop and loop around. Keeping in mind that using the definition, scooping and looping around only works when you have one log and a number on the other side. All right, doesn't matter what side, but one log and a number on the other side. All right, we're going to take a look at number 7. I'll fit it over here. And we have 2 log x plus log 4 is equal to 2. So I can't scoop and loop around because I do have 2 logs here. So I'm going to first start off by condensing using my log properties. The first thing I see is that 2 in front. I'm going to bring that to be my exponent using that power property. And then now I see on one side, I have 2 logs in addition. I'm going to go to one log and I'm going to go to multiplication. And there's an application of my product property. And then now that I have one log and a number on the other side, I can scoop and loop around, and I can rewrite this in exponential form. And that's 10 squared is equal to 4x squared. And then continuing to solve for x, this is 100. Dividing on through by 4, I get 25 is equal to x squared. And then now we're doing those inverse operations. So I'm going to take the positive or negative square root. Keep in mind that when you have a square root in a problem, you're using the principal root. But when you apply a square root, you have that plus or minus there. And then now plus or minus the square root of 25 will be positive or negative 5. All right, so we have 2 x answers here. We have x could be positive 5 or x could be negative 5. So we're going to go ahead, we're going to check like we do in all of our problems. Mentally checking here, well, if I plug 5 in here, my domain is going to be positive. My 4 is there, my domain is positive. X equals 5 is an answer to this problem. All right, so I'm going to highlight that. And then now looking here, when I plug in negative 5, I have log of a negative number. This is not a solution. This is going to be an extraneous solution that arises from doing the problem, all right, but is not a solution to the original. So you do have to keep in mind, all right, you can only have a domain that is positive, okay? So there's a negative number, I plug it in, all right, and it does not work out. All right, we're doing good here. We're on 7 out of 10. Woo! We're going to take a look at number 8. Number 8. 2 log x minus log 3 equals 2. All right, this one's very similar to the last problem. We're going to condense first using that power property. So bring that 2 to be an exponent. And then further condensing, I go from subtraction with 2 logs to division with 1 log. And that's an application of my quotient property. And then when I go ahead and I scoop and I loop around, I'm going to rewrite this in exponential form to solve. And that's 10 squared is equal to x squared over 3. Well, 10 squared is 100. Is equal to x squared over 3, and then x squared is equal to 300, and then taking that plus or minus square root on both sides, plus or minus, we're going to get here that you could use calculator because Miss Marfleck did. I get plus or minus 17.32 is equal to x. So we have these two solutions again. X can be 17.32, I rounded, or x can be negative 17.32. When I go ahead and I double check, I need to check into the original problem. All right, you're not checking into the second or third step where you square it. Original problem. And when I plug that 17.32 in, I get a positive domain. That one works. All right, but when I plug that negative 17.3, I get a negative domain. And that one is an extraneous solution. All right, looking good here. Two more. We're going to take a look at number 9. We have log 6, log 6 minus log 3x is equal to negative 2. All right, no power in front, just condensing using that quotient property. Subtraction with 2 logs, we go to division with 1 log. And then I can simplify inside parentheses first. You don't have to. You will get the same answer if you simplify later. All right, but I'm going to simplify. 6 over 3 is 2. And then I scoop and I loop around. Here's my common log again, which most of your problems in your homework will be, and that's 10 to the negative 2 is equal to 2 over x. And then 10 to the negative 2, well, that's 1 over 10 squared. And then 10 squared is 100 is equal to 2x. All right, and then now we have this proportion or this ratio here. We're going to use our butterflies or our cross product, and we're going to have 200 is equal to x. And then going back and mentally checking in with the original problem, if I plug in 200 in for x here, we're going to get out a positive domain, so that is a solution. All right, one more, and here we are, number 10. All right, I'm going to put a big C here because number 10, I think, is a challenge problem. All right, and then after tomorrow, when we take a look at some more examples like number 10, it won't be a challenge problem. Here we are, log base 2 of x plus log base 2 of x minus 7 is equal to 3. All right, we need to use those log properties first to condense everything on one side to then scoop and loop around. So I see addition with 2 logs. That means I'm going to go to multiplication with 1 log. So I'm multiplying my x times my x minus 7. And then notice that extra set of parentheses there because I have to multiply the x by the x and by the 7. I like to simplify it inside first. That's my personal preference. If you don't want to simplify, you want to simplify later, that's okay. All right, so I'm simplifying first. And then now that we have 1 log and a number on the other side, I can go ahead and scoop and loop around. And I'm going to rewrite this as 2 to the 3rd is equal to x squared minus 7x. And then now it just becomes like any other equation. The log is gone. Your goal is to solve for x. And we know how to solve equations like this. This is a quadratic. And we have all of these tools in our tool belt to solve quadratics, and we always try to start with factoring first. All right, notice how I subtracted the 8, and then I just rewrote this on the left-hand side. So I didn't subtract x, and I didn't add 7x. Instead, I just subtracted 8, and then rewrote this on the left-hand side. And then we know how to factor this. Our 2 numbers that are going to multiply to negative 8, but add to negative 7 is going to be a negative 8 and a positive 1. And then solving for x using that 0 product property, we get x is equal to 8 and x is equal to negative 1. We're going to start off with that 8 first, and we're going to plug it in to the original. Well, if I plug in 8 here, my domain is positive, and then 8 minus 7, my domain is positive. So 8 is a solution. All right, but then when I go ahead and I try to check my negative 1, I plug in negative 1 here, I get a negative domain. Right off the bat, that one does not work. It is extraneous. All right, like I said, I know we went through these pretty quickly. We did 10 examples in 20 minutes, which is, 2 minutes per problem, but you have the ability to stop the video, pause, and rewind. You can also go back and start this video and put on, in the settings, you could play it so that it goes at double speed, and then now you're quickly maybe going through the video. All right, but you really need to take a look at these examples while you're doing your homework. They will be very, very similar. All right, more videos will follow, especially looking at examples like this where we have to factor, and we do have another type of log equation which we haven't seen yet, so we're going to see that in the next video. All right, make sure you do your homework and then email me if you have any questions.